everyone. Welcome to today's workshop. Today we're doing a very interesting workshop where we will make our own Sudoku game and solver using Python and with a bit of AI. So first, let me talk about the assembly. The assembly is a smart lab based in N5 since December 2014. We have done more than 253 workshops, which belong to 3 categories. First, the hack workshops, and these are about embedded systems, IoT, and hardware. The second is code, which is all about software projects using APIs, frameworks, and apps. And finally, the third one is data science, which is the category this workshop belongs to, and is about topics related to AI, deep learning, and machine learning. The audience we target are students, professionals, and entrepreneurs, but anyone who's interested in these workshops is more than welcome to attend. We mainly focus on teaching and using smart technology and its practical applications. For more information, feel free to visit our forum on members.theassembly.ae. Also, find us on our social media at The Assembly on Facebook and YouTube, and at Make Smart Things on Instagram and Twitter. Now let's begin with our workshop. So we will start by explaining the topic of this workshop. Then I will give a background and explain some of the basic features of Python. Then I will explain the backtracking algorithm, which we will be following in our project. And then I'll show you an example, and finally the programs we will be using. So as I mentioned, we will be using the backtracking algorithm to create a Sudoku game and solver. Yeah, so Python was released in the late 1980s, and it's the third most used language today, as it's easy to learn and use, which makes debugging cheaper and simpler. Python is very popular nowadays, as the most common applications we use it, such as Instagram, Google, Netflix, and much more. Some advantages of using Python include its multi-purpose extensive libraries and the object-oriented simple language. Now, moving on to the basics of Python, blocks of code are determined by indentations. Variables do not need to be declared beforehand. One equal sign is used as the assignment operator, while 2 equal signs are used for the comparison operators. And we can concatenate strings using the plus sign. We have 3 logical operators, and, or, and not. And finally, we can also have some chained assignments and assign multiple names simultaneously. Now, the backtracking algorithm we will be following, it works by finding the solution incrementally and in a recursive manner. It tries different possible values and removes the ones that do not satisfy the constraints. So in other words, we will try the allowed values for each cell. This means that the value is not already present in the row, column, or the block. So if the number is still not possible, then we will delete it and try the next value, and that's where we backtrack. Now I will compare the normal approach, or in other words, the dynamic programming, which just tries all the possible number combinations, to the backtracking approach, which drops a big set of permutations every time it backtracks. This shows that the backtracking algorithm is better as it saves time and it needs a lower number of tries. Now here, this is an example that uses backtracking algorithm. As you can see in the first cell, the solver does not try number 2. Does not try number 3. It jumps from 2 to 4 directly, since 3 is already present in the row. So now what to install? I'll be using PyCharm and Pygame, so I'll show you how to install the libraries we need and to open a new project. Okay, so after installing Pygame and PyCharm, you will need to open your command prompt and type in this to install your libraries. It might take some time. Okay, and then the other one is for the Pygame widgets library. Okay, so now you can start working. Okay, so I started by importing the libraries we're going to be using, and after that, I put a function which will give us the position of the player. So we have two variables, x and y, and then we're gonna set them based on the dimensions of our board and using the increments that I will be defining later in the main. So next we'll be drawing the grid. So define draw grid. Okay. So I'm gonna have okay. So we'll have a nested loop, nested for loop for the rows and then for the columns. So this takes us from 0 to 9. Okay. So in my solver, I'm gonna set 0 for the empty cells, and then the non-empty cells will not be 0. So here we're trying to find the non-empty cells. And if grid it's not equal to 0, so it's not empty, we will use the Pygame library to draw some colored rectangles. So Pygame.draw, or like tiny squares. I'm gonna set the colors using the RGB standards. And then here we're gonna set the positions. So okay, so this will fill the non-empty cells. Okay. And now next we're gonna insert the values, the default values from the grid. So we're gonna use the render function and the block transfer functions. So we're gonna say text is equal to and this will help us get the font. The position on the class. Okay, and then now to the block transfer function where we will be putting the values into their position. We'll be passing it the text and then the position, X and Y. Okay, now we need to draw the lines of the grid. So we will have another loop. And here we're going to make a attempt to have it all over the sides. So we're gonna have if I modulus 3 is equal to 0, which means after every 3 blocks, after every 3 cells, we're gonna have a thicker line to separate the blocks. So if sorry. Modulus 3, we're gonna set the width to 10, and else we will keep it as 5. Okay, and now we're gonna draw the lines using the width of the. We're gonna draw the lines using the width we set for each case. So PyGame. The color and then also the positions. And then we're gonna add the width. So this is for the horizontal, vertical. Here we can see here it's the vertical, and then we're gonna do another one for the horizontal. But we're gonna okay, so we're gonna switch these, like flip them. And 500 is the size of the screen, so I'm gonna add this later. Okay. So that's it for drawing the grid. Now we will, okay. So next we're gonna, so now we need to highlight, we need to highlight the selected cell where the player is currently at. So I'm gonna do that using another function. Define, let's say draw selected. We won't pass it any attributes. So here for so it's only going to be one square at a time at the position where the player is currently playing. So here we're going to draw two lines using the PyGame library. Screen and colors. Now this is from the position function we had over here. Okay. So this is the width of the square, and we're going to do another one for one is for horizontal and then the other one's for vertical. So we're going to have the same thing, but instead of, we're going to flip X and Y. And then so now I want to add a button that will solve the game once the player clicks on it. So another function for that. Draw the solve button. So that's called the button. Now here we're going to be using the PyGame widgets library. place it on the screen, and then I'm gonna put the position of the button we'll be adding. And then I will set the font size and the colors and all of the specifications. And then using the Pygame, the Pygame function, the Pygame library, I'll draw it. So okay, after that, I will so now next we will put the game mode. So basically the player can pick whether he wants it easy, average, or whatever he wants. So I'll do this using another function, and here we're gonna have draw the game mode. So draw modes. These are all defined functions that Python allows us to use. So sorry. And then the attribute font. I'm gonna set some of the fonts that we will be using in the game modes. So this is the other one for the attributes. Here we go. Okay, and then here we're gonna have the game settings, and then we're gonna put the colors and the position of each of them. There's clear, and then there's easy, average, and hard. You're gonna see how this looks once we start running the code. Now we're gonna start solving the game. So we're gonna put the backtracking code to solve the game. So solve, or let's say, okay, solve grid. We're gonna pass it the grid array, and then two positions, I and j. So I'm gonna define a global variable, which is solving global is solving. And I will set it to true at the beginning. It's just like a flag. So next we're gonna say that while the grid array is of the two positions I and j, while it's not empty, so while the cell does not have a 0, so not equal to 0. Okay, so now we're gonna loop through the entire grid. So we're gonna start by the rows and then the columns, and then we're gonna check the entire block. And if the value is not there, we should return true. If the value is already there, we should return false. So I'll do that now. So if while I is like, we're gonna inside the while loop, we're gonna check if I is less than 8, since there are 8 blocks from 0 to like 9, basically 9 cells. I'm gonna increment it, so I plus equals 1. and then we're gonna check the columns. After I is 8, so basically after I reaches the end. So once we're done with the row. So that's 8. We're gonna increment. We're gonna set I to 0 and increment J. Equal 8, and J is also 8, so which means that they're both, we're done going through the rows and the columns, so J is equal 8. Now we can return true. Okay. So this means it went through the entire cell, like the entire blocks, the entire grid, I mean. Okay. Okay. Now we're gonna try the values from 1 to 9, and we're gonna make sure that they're already not present in the row, column, and the block by the previous thing I did. So for 1 to 10, which means like from 1 to 9 inclusive. Okay, so here we need something to see if the user's value is valid. Okay, so define is user value valid. We're gonna pass it the positions as well, the value and the positions, and okay. So I'm gonna say for I2 in range 9. And then so now we're checking the rows and the columns. And then here are the columns. So if the value is present, then we're going to return false. Return false. And then we're going to check the boxes and the blocks. So we're going to set I2 and J2 to 2/3. For I in range of we're going to have a nested loop for I and for J. Okay, so the same thing again. If the value is present in the block, so if the grid of I or the array of ij is equal to the value, then we're going to also return false. Okay, else we're going to return true. You don't need this, but it's fine. So we're going to go back to this function which solves the grid. Okay, so if the user value is user value valid, so we're gonna use this previous function here, and if it's true, we're gonna pass it the parameters. So first thing is grid array, I, j, and the value. So if it's true, we're gonna assign this value into the grid. So grid array of I and j is equal to the value. We're gonna add the value to it. Okay, so if the value is correct, we're adding it to the grid, else we should keep the box empty. So here we're gonna have else grid array I and j, we're gonna keep it empty. Zero. Okay, so then we're gonna I'm gonna add some of the Pygame library functions, which will help us finish the rest. So now we're gonna add a function to allow the user to insert the values, also using the render and the block transfer functions. So define insert value, and we're gonna give the value. So we're gonna put the position of the grid. So grid X and Y, the positions we set before. So X, and then I'm gonna change it to an integer Y. Okay. And I'm gonna add here the value. Okay, and then so we're gonna say text is equal to A. And then the color of the. Okay, and then using the screen, the block transfer function, we will be able to print the values using the text we specified before. I'm doing this just to set the position, so you can try the values, and then you're gonna find the proper position to make it centered. So now the next thing I will do is define a function for the user. So basically to know whether the user won or not, and the user will win when there are no more zero, like we don't have any more zeros in the cells. So it's just a very simple nested for loop to find it. So define is, or okay, user won, and that will happen after for I in. We're gonna go through the entire grid. So for I from 0 to 9. Equal to 0. So if we have a 0 in the grid, we're gonna return false. Else we're gonna return true. Oh, not here, sorry. We need to take care of the indentations. Okay. So now, to enable the player to use more than one grid at a time, I'm gonna add a function that will, and I'm gonna add different grids to it, where the mode 1 is gonna be the first grid, second, and then third for different grids, different difficulties. One's gonna be easy, medium, and the hard one. I'm just gonna add the grids now. So we're gonna have mode equal to 0 for clearing the grid, and then 1 is for the easy one, 2 is for the average, and then 3 is for the hard one. So basically we're gonna have 3 different grids. Okay, next we need to specify what each button on the keyboard is going to do, and this is, we're gonna do this using the Pygame library. So okay, so I'm gonna define a function. We're gonna have the grid. And I'm just specifying some of the values. So now I will add what each button should do to the game. I'm just gonna write it all at once to save time. Okay, so first, if the user wants to quit the game, we're gonna use the Pygame library for this, and then we're setting all the arrows left, right, between, we're gonna move x +1 or -1 and all that for x and y. And then the values, I mean the numbers to enter each number, the value of the user. Okay. And then this is also for the button. Okay. Okay, I'm gonna have another function to display messages directly, so I don't have to write it down every single time. So I will do this using, okay, I'm gonna add another one. So yeah, define display message. And the time interval, how long do I want it to stay for? And let's say color. Okay, so, okay. I'm gonna use again the render and the block transfer functions. So text is equal to and then we're gonna say screen. I'm just gonna do it all at once. So instead of having two different. Okay. Okay, and then I'm just gonna use some of the other functions which will help us update the screen and set the time and everything. So here we're gonna set the time interval based on what we want. And okay, this is just to avoid writing it every single time, doing all the steps all over again. Okay, so now, okay. So now we're gonna use the function to display the messages when the user is done with the game, or if he inserts a wrong value, or so basically to make it interactive. So define raw user value. user value is greater than 0, if is user value valid, this is a function we had before. Here. So if is the user value valid, we're gonna pass it the values and then the user value. Fine. You can say the and then y. We're gonna use insert. So if the value is 0, we're gonna insert the insert value of the user value. Okay, and then we're gonna set it to 0. Value is equal to 0. And then if the user won, using the function we also did before, okay. So if user won, we're gonna say that we're gonna stop solving the game, and we need to display a message that the user already won. So is solving is equal to false, we're gonna stop solving, and then we're gonna display a message. Okay, so display a message, and we're gonna say 1, and color and the let's say 2 times. Else user value to 0. We will display that the value is incorrect. Correct. We're also gonna set it to 0. So we can just get rid of this. Okay, so now we're gonna do the game, the order of the game. I'm gonna put that in a function also to make use of them. So okay, so define initialize. I'm just gonna put all the functions I used in order. So first we're gonna draw the grid. Okay. And draw the selected box. And then we're gonna draw the modes, which means like we're gonna print the values and all the text we wrote. And then click the solve button. Okay, and then we're just gonna update our screen. Okay, so now to the main function here, I set all the values for x, y, and the increment. This is the screen size divided by the number of boxes. And then here are just the fonts and everything. And then, okay, after that, I'm gonna add more values, which are going to be here. Okay, so I'm gonna add the grid and like the user value. So the user value which is 0, and then I'm gonna add the grid. And I will assign is running and is solving. And then finally the game shuts on. Okay, so that's it for now. I'm gonna run the game. Okay, so here we have our game. We can move around and we can play and we can even solve it. So now I'm gonna start by solving it. This might take some time because the backtracking algorithm is not the fastest, but here you can see it's not trying all the values, it's just trying the values that are not present in the column or cell or the block or the row. And once it reaches a point where it can't continue the game, it goes back. That's where backtracking happens. Okay, so this will take some time. Okay, and now we solved the game. So now I'm gonna run it again and I'm gonna play the game. So now I'm gonna play the game. I'm just gonna put in the values. So let's say I'm here. If I insert number 6, it gives me a notification that it's an incorrect value since it's in the same row and column. So for example, if I come here and I put 9, same idea. I can't put it if it's in the same block or column, or so I'm gonna try 1 over here. It doesn't work as well. So I'm just gonna put in the correct values now. So now once you finish the game, it also gives you a notification that you won. You can change the notifications and the messages as the way you want it to be. And yeah, that's it. Thank you so much for watching today's workshop. So thank you for watching this week's workshop. I hope you enjoyed. Make sure you follow us on our social media accounts. Thank you.